gonna start recording. All right, and this is an intro to game hacking and game reverse engineering. So just some quick announcements. There's several Capture the Flag competitions this weekend that we will be competing in. Specifically Sunshine CTF, which is put on by our good friends at Hack UCF. So that's definitely one that you should look to get involved in. It'll be a lot of fun, and if you're in the pen testing class, it's a great way to earn your hours. Our blue team meetings are Mondays at 6:30. Red team meetings are Tuesdays at 6:30. And you can follow those Slack channels, and then also for Red Team, the CPTC server on Discord. And then Cyber Range is still happening virtually on Wednesdays in a Discord voice chat. So when you see Owen basically hop in a voice channel on a Wednesday around 6, that's when you know Cyber Range is generally starting. And you can hop in that voice channel and collaborate with him and anyone else who comes on whatever CTF problems you're working on, or reverse engineering, binary exploitation, really anything you want to learn. That's a great way to develop your skills on your own time. And now I'm going to turn it over to Paul. He's an alum of the club and currently working for EA, and he can introduce himself further. But I will turn it over to him to conduct the rest of the presentation. I want to thank him for taking the time out of his schedule to present to us. It's really cool of you to do that, Paul.
Yeah, no problem. So here, let me get my slide up and running. All right, does that look good?
Yes, yeah, we can see it.
All right, so as Claire mentioned, my name's Paul. I graduated about 1.5 years ago, around there. And right now I'm working as a game developer. So usually don't mess around too much with game hacking, but I started getting into it recently, actually to make a Discord bot, and it kind of just went down a rabbit hole from there. So first, some warnings. Nobody likes when you hack games. It's really annoying when you're playing online and somebody is hacking. So just don't do it. Do it just for fun, you know, like offline or just messing with your friends or something like that. You should definitely not get money involved if you start selling or distributing these types of things. There haven't been any like Supreme Court cases that I could find, but you could get sued. It's kind of a gray area. Okay. So the first thing that I'd like to bring up is the graphics reversing part of the presentation. So usually this is more of kind of just for fun. You don't really have to do this. It gives you some useful information about kind of like the API that they're using to render the game. So this could help you later on if you're trying to like hook API functions, or you know, just kind of render things to the screen, like make a modded type game. So you can also, So if you're like me, I am a graphics engineer, so I think it's really fun. You can learn a lot about how the game is rendered. You can see pretty much every single draw call that is on the screen, or that is resulting in the things on the screen. You can see how they set up their texture information, how they, you know, are compressing their information. It's just fun. Some of the useful, or the most useful tool for graphics debugging is called RenderDoc. So what it'll do is it will inject a DLL into whatever process, in this case our game, is trying to render to. So you can just attach it, take a capture, it'll collect all the GPU resources, it'll collect all the raw calls, it'll collect, you know, every pipeline state for the GPU that is running, and you can debug that slowly. You can even rerun it. You can debug the shaders there. It's an extremely useful tool. It also has a Python scripting API, so you can automate things in there. You could automate the debugging process if you want. Again, this is mostly just for fun. I actually have done this before. I did a presentation on it with the new Doom game, Doom Eternal. So this is the result of using the Python API to save out one frame of information as it's being rendered. So here you could see all of the meshes being drawn out one by one, kind of just as the frame gets built up. So it's pretty interesting just to kind of see how AAA games are ordering their frames to get, the maximum performance. And the frame is about done. You can see how it tries to focus on objects farther away. Or first it does your weapon in your hand, and then it focuses on objects farther away, and then it kind of moves its way back. There's important reasons for that, like in rendering at least, to prevent like see-through objects from not having objects rendered behind them. So you kind of have to render back to front. And then you can see it added dynamic meshes afterwards. The highlighting that you're seeing there is actually like motion vectors added on top of them. So those are the objects in the scene that can move. So that was just a quick rundown on graphics. Since it's really not the most important part, that's mostly just a curiosity. I'm going to get into like what assumptions we can make about just a game binary on its own. Games are just large executables. Usually it's just a collection of DLLs, just kind of mangled together, especially if it was made with an engine like Unity or Epic Games. So, it's just a large library essentially that the game is calling from. Another one we can assume is that the game is going to render to the screen. So, this is how you interact with the game. You see the graphics, you see, what it's doing on the screen. The game has a state inside of it. So the state is what we are actually going to be trying to change here, or reverse engineer. We want to be able to change this state to kind of just fit whatever we are trying to do with the game. In the case of the example that I'm going to show you with Among Us, I wanted to see, or I wanted to change, the outfits of the players, or, set certain people's names, or, kind of mess with things like that. So that would be the state that you're trying to mess with here. And there's two methods that you can use to interact with that, external and internal hacking. I'll get more into that a little later. So obviously the next part is, there is logic to manage that state. The state would represent the actual memory, and the logic of the state would be like the game programmers, programming the game to manage all of these things in memory. So this is where we'd get into internal hacking specifically, where we're messing with the actual logic of the program. So as I mentioned before, there's external versus internal hacking. External hacks are the ones that your target or your reverse engineering program is not part of the same address space as the game, essentially. So you would utilize the Windows API to like open up the process, read memory, write memory, do things like this to, you need, to find the things in memory, pattern scan for them, and try to edit like that. It's more of a grueling process in my opinion, but it can be useful. Internal hacks are ones that are in the same address space as the executable, in this case a game. So usually you do this with a DLL injection. So we would write our own DLL, we would inject it into the target process, and then we would, from there you can execute your own code that's in the same address space as the game. So there you could like easily reference functions in memory. You could usually reference classes in memory, especially static instances of classes become really easy to mess with. So there is actually a great example of external hacking by a YouTuber. Well, I have a link to his GitHub here. So what he did was he pattern scanned through all of the memory, or not all of, but a lot of the memory in CSGO. And he found the addresses for a ton of useful things like the trigger pulls, simulating mouse events, simulating the player's movement, teleporting the players, killing players, all the things like this. And he actually used it to kind of mess with people. So here, I have a little clip here. So whenever people download his hack, he actually has the player. Yeah, 1 second. So what you're going to see here is he distributed his hack to people who thought they were going to be able to hack, and whenever they turn it on, it ends up killing them or shooting them off the map or something. So this person thinks that he's going to be able to hack, and he made it, do whatever he wants. And this was all achieved with external hacking. So it's kind of just funny things to see, or messing with people like this. Yep. You can see the player loses control. That was just a quick example. So if you want to see his GitHub, you could go here and you can actually look to see the addresses that he found in CSGO. And you can even, download the project and run it yourself. So we have a good amount of tools that are going to be involved in game hacking. So the first one, and one of the easier ones to get into, is called Cheat Engine. So Cheat Engine will be used to pattern scan memory, or it's kind of a live debugger. So you're going to be using it to check for certain things in memory, or trying to find structures in memory, static instances of classes, RVAs, so things like that. The next one is a DLL injector. So I'll actually show a quick example of how to write one of these. Essentially, this is just used to inject the DLL into the game. So, or a DLL that we write into the game. You're going to need a code editor. It's pretty code heavy, actually, to make some of these internal hacking examples. So anyone is fine. I recommend Visual Studio just because we're going to be working with Windows here, and it's a lot easier. Ghidra, or any debugger for static analysis. I think this tool, another tool a couple items down, is going to generate dumps for Ghidra or IDA. So I would recommend using one of those two to make your life a lot easier. On x64 DBG, you can use this for dynamic analysis. It's not necessary for a lot of cases, but it is useful, like if you want to check your changes or set breakpoints on functions to see if your RVAs are correct that you're getting from Cheat Engine and things like that. I'm actually going to get into Unity games specifically here towards the end of this presentation. So a couple tools that are specific to that are IL2CPP, which stands for Intermediate Language to C++. So Unity games are actually written in C#. And so what Unity has is a package that converts this C# code down into C++, and then it converts that later on or it compiles that down later on. So we can actually abuse this process here to get a really good decompilation. DNSpy, that is a C#/.NET debugger that's just useful. IL2CPP inspector/dumper. So those are community written tools that we'll use to abuse IL2CPP. And I'll get more into all of these later. So the first one, Cheat Engine. Cheat Engine is a memory scanner, like I mentioned before. You can use it to view and edit memory of a live process. So you can actually attach it to anything you want. But obviously we're here to do game hacking, so we're going to attach it to your game. And you can actually search for things inside of that game. So one of the features that we're going to want to use here is it has like pattern scanning and pattern matching. So you can say, okay, I know what a structure looks like, or I know what structure I want to look for in memory. You can set this pattern, and then you can search for that in like your live process memory and find, all types of things. And then you can actually edit them live, and it would take place or take effect on your game. So I just have a couple examples of like the basic usage of Cheat Engine. You could probably do a whole presentation on it. It's kind of a big tool. So I'm just going to keep it brief and show some really quick examples of how to use it. So the first thing we're going to do is, after you install it, you just, which you can find online, it's just a GitHub page. So there'll just be like a little search in the top left corner, as you can see here. You just open that up and find whatever game process you want to debug, and then open it. To start scanning memory, you'll notice that on the right here, you have this new scan option. You'll definitely want to click that new scan option and then select the scan type. So this would be like the data type that you're looking for. You could look for strings, floats, integers, anything you want. Ideally, what you want to search for, because it'd be kind of hard to know what you want to search for, is something that you know. So I'm sure a lot of people here have played Among Us, and at the beginning of the game, there's like all those options on the left, and those are all numbers. So and those are numbers you can change in game, which is more important. So you can say, look for the kill cooldown, which I had set to 40, as you can see here. You can search for that kill cooldown. Then you can change the kill cooldown in game, search again, and then you'll actually search again for that new value, and you'll actually get the memory addresses that pertain to where that variable is in memory. So then you'd be able to change them live. Like I when I first did this, I messed with the movement speed and made the movement speed like 2000 or something. So the neat thing about Cheat Engine is that all the scans are consecutive. So like if you do your first scan, you'll have a set of results. The next scan that you do will only be from those set of results. So it actually won't contain the rest of the program. So you can really start narrowing down things as you do more and more scans. So as you can see, I changed the value in the game to 42.5 from 40. I did another scan now for 42.5, and you can see that instead of having that giant list of memory addresses, now I have 4. And so these are probably all referencing the same thing. So these are all that variable in memory. So now we successfully found where the kill cooldown goes. So what you could do here is you could just straight up, right click that value and change it to 0 and make the kill cooldown 0. It's as easy as that. So a lot of what we want to do though is not simply just changing variables. We usually want to find structures. We want to find actual classes and things like that in memory. So the first thing we'll do is I just did another scan and I searched for my name. You can see I have a bunch of results coming up. Which one is the real one? What you can actually do is add them to this menu down here. You just double click them, and then you'll be able to browse their memory region. And so let's see what that'll look like. You'll end up with this hex dump of the memory region. And you can see down here in this hex dump, you can see my name, which is the string that I searched for. And next to it, it's going to be kind of garbage. It's just going to be random values. You can kind of play with it and see what these values are. And that will actually, so that will actually, you could find like important information that's packed into structures. So like, let's say the structure that your name is in, let's say it has like, if you're an imposter next to it, or your movement speed or other things like packed into the same structure, they'll usually be next to each other in memory. So you'll be able to see them here. So now I want to start getting into internal hacking. One of the most important tools that we have for internal hacking is injecting our DLL. So as I mentioned earlier, a DLL injection allows us to run our code inside the same address space as another process. And for another more advanced topic, this is absolutely necessary if you want to be calling game functions and hooking game functions. But first, what is DLL? I've been mentioning it a lot. It's basically just a shared library. So instead of having a built-up executable that runs its own main, kind of like we're used to, it is just a library that can be loaded at runtime by another program, and it'll just have a set of functions. So we would write a set of functions that we want to operate on the game address space, and then we'd inject that DLL into the target process to execute them. So I'm going to go over just real quick a basic DLL injector. You probably don't want to use this on any AAA games just because they usually have mitigations for it and you might get banned. So let's just assume for a second that we actually have a DLL and we want to inject it. So these are the steps that we're going to have to take. So we're first going to have to attach to a process, attach the DLL, I mean. we're going to have to allocate memory on the target process for the DLL. Then we're going to have to copy the DLL path, like the physical, file path to our DLL that we want to inject into the process memory of the target. Then we're going to want to create a remote thread on the target process running load library A. And then this will force our DLL to be loaded by a remote process. So I'm going to, kind of break it down step by step like I just did. So the step one is to attach to a target process. So I actually have some code here. So you can see from this diagram, we have the injector process, and then we're going to attach to the target process. As you can see here, you have your path to the DLL. You have a proc ID, you have your process name, sorry, and then you have your proc ID. So we need to find the process ID, which is what will appear in your task manager for a process. There's a little function here that can be found anywhere called get proc ID. You give it a name and it'll return the proc ID. Then we will want to open the process. So these are Windows API functions. They're extremely useful. I'll definitely check out MSDN if you have any questions about these functions. But this will actually give us the handle to the process. So now after executing open process, we will have a handle to the process in memory that is running. So now we want to allocate some memory on the target process so that we can fit our DLL into it. So you can see here, I just check if hproc was correct. And then I get the address of load library A. This is just to be used in the future. So you can see I use kernel32.dll, which is the DLL that load library A is a part of. I use that as a base address, and then I search for load library A inside of there and get the address for it. The next part here is what I was mentioning, where you allocate memory. So you can see here that we're allocating memory on our handle or on our process. This third argument here is the size that we're going to allocate. So we're just allocating enough size for the name of our DLL path. And this mem commit and mem reserve is just saying that you want the memory to be in working memory. So now we are going to copy the DLL path into the target process's memory so that we can use it. So you can see in this if statement here, we're actually going to write process memory. And we're going to we're going to use write process memory, which is another Win32 function. We're going to use the DLL path that we specified earlier, and then we're going to give it a length that we used before. And then finally, for the last part, we're actually going to create a remote thread on the process that is going to be running that load library function that we got earlier in the code. So you can see here, there's a convenient function called create remote thread for that in the Windows API. And so you'd create remote thread with the function address that we gave it. And then now your DLL should be loaded into, or loaded by that remote process. So now we can talk about what is the DLL, or where do we get that DLL from? So we're actually going to be writing it on our own, and it's not too different from making a DLL, making a regular program. So first we just created a DLL project in Visual Studio, which is the easiest way in my opinion. So DLLs are Windows only. That's why I'm using Visual Studio here. Yeah, so Visual Studio actually has a convenient template for us, which I will show. So you just create a new project, and then you'd give the project a name, and then you'd search for the DLL template. Just click on it, open it up, and now you'll actually have this project set up. So this is the template that it gives you, and I'm going to explain what it all is right here. So normally in your normal programs, you have your main, which is your entry point into the program. DLLs are slightly different. They have DLL main as their entry point. And so the DLL main can get called for a number of reasons. And as you can see here by the code that was completely generated for us by Visual Studio, DLL main can be called by a process attach, a thread attach, a thread detach, and a process detach. There's a couple more, but they're not really that important. So you can use this to run our custom functions. So what we're concerned with is process attach. So whenever we attach our DLL to a process, we want to be able to execute our own code on it. And so that function call is going to be where we're going to be actually, modifying the game logic. So after you have your DLL, I'm going to get more in depth on what kind of information we want to put there, but just know that, once you have your DLL injected, you're going to want to have, or your code will be executed in the same address space as the game process. So then you could use this to call game functions if you have the virtual addresses for them, things like that. So here's just like a quick example of what we would be doing, or like some hack stuff. So this was again for Among Us. You could see that on DLL process attach, I create a thread, and then I create the thread with this do hack function up here. So right here, you could see, I know I have the, or I'm pretending to have the RVA for this function right here. I typedef the function, so now I have a function pointer to that function. I create an instance of that function, and then I assign that instance of the function to the RVA of the function. So like I obviously didn't have it here, but you can use Cheat Engine, you can use dnSpy, you can use even Ghidra, or not really Ghidra, but you can use whatever debugger you want to get the RVAs to the functions, and this is how you'd call them. And so then down here, I actually use the function. So now I actually want to get into a bit of like the specifics of Unity game hacking. It's a slightly different process. Unity games are a special case, again, because they're written in C#, but C# is kind of like a Java-like language. It's not really a good idea to write games in C#. So to maintain performance, Unity actually converts their code to an intermediate language. And then they can use that to convert it to C++, and then to not bytecode, but assembly from there. So this tool is actually built into Unity. This is a library made by Unity. It is their tool called IL2CPP. We can use it to get some extremely useful disassemblies, and we can get all sorts of information like function signatures, RVAs, class structures, things even more advanced than that, but that I won't cover here. So first tool here, IL2CPP Inspector. This is the tool that we're going to use to generate kind of the, I guess, scaffolding that would create a C++ program out of a Unity program. And so this is what IL2CPP is doing. So what we're going to do is use IL2CPP with this tool to generate the exact same thing, but unoptimized and in ways that we can actually read it. So like mentioned in this text here, you can see that we can actually generate a Ghidra project. We can generate a DLL injection project with this. We can generate information about all their function signatures in dnSpy, and I'm going to actually get into all this. So if you actually want to download it, this is a community tool. So IL2CPP Inspector is a community tool. So you could find the person who made it on GitHub. You can just download it, use it as however you want. I would recommend when you do get it, though, to use the GUI version. I actually tried using the command line version, and it was super buggy, broke down a lot, and, like, kind of ignored arguments sometimes. It was really weird. So after you actually get the project and build it, you'll have the actual application, your IL2CPP inspector. And now what we're going to want to do is we're going to want to generate a C# dump of the game code. And so this is what we're going to use to actually start reverse engineering the game. There's a lot of setup involved in reverse engineering Unity games specifically, just because it's the way they're structured and like, you know, since they're converting to different languages. So there's a couple things that come with IL2CPP, or with Unity games. You're going to have a metadata file, and then you're going to have a DLL that contains the game code. The metadata file is going to have all the information from how the game was when it was in C#, and then the game code is actually going to be the compiled down version of that, of the .NET/C# code. So this is just an example path. So from Steam, your Steam root, you could just find your Among Us game, and then it'll actually have folders just called Among Us data, you know, IL2CPP data, and then metadata. And then that'll actually just, you'll see a file in there called metadata that you'll be able to, that you'll be able to use. So I can actually show you a quick example of that. So from your Steam root, you just go to Steam Apps Common. You can see here's all the games I have installed. You can open Among Us. There's Among Us data, IL2CPP data, metadata, and then there you go. This is the file that you're going to want to look for here. So next, you're going to want to find the gameassembly.dll. That's actually in the same place as what we just did, just a couple folders back. It'll just be with the main Among Us executable. So with Unity games, the gameassembly.dll is actually where all of the game code lives. So there'll be the, you know, Among Us executable, and then there will be the gameassembly.dll that is all the game like code. So over here, you'll see the what IL2CPP inspector will look like when you open it. So those two files that I just mentioned, the metadata and the gameassembly.dll, they'd go in here. So option 1 would be the metadata. Option 2 would be the gameassembly.dll. And after you put those in, this is where you can actually start selecting what type of project you want to generate. So you could actually have IL2CPP inspector generate a DLL injection project for you, as you can see down here. I have circled. So this is kind of where it starts getting, you know, involved, where we can actually start doing things with the game, and we could actually start reverse engineering it. So I would recommend, you know, you generate that project. So this is the project structure that will be generated for you. You can see it looks similar to what Visual Studio did for us. As you can see on this left part right here, it's just like the same, you know, DLL main stuff. And it'll give us this create thread, and it has its own function that it wants us to use called run. So what the additional information that it does provide us, though, is the app data folder, which you can see over here. So the app data folder is going to have all sorts of useful information in it about every single type that's in the game. It's going to have information about every single function in the game, and it's going to have every single bit of, or all the information about every class in the game. And it's all going to be converted from C# to C++. So over here on the right, you can actually see I found the video player for the game. Just, it's, you know, right there. And then inside of these structures that are members of it, you'll find like the actual members of the class. So this is extremely useful. Now we actually have a conversion from C# to C++ that we can actually call in our code. So in our run method, we could just create an instance of this video player class, and we can, you know, kind of start doing whatever we want. So the next thing we're going to want to do is set up a Ghidra environment. So I'm sure a lot of you have used Ghidra. I'm not going to get too much into it just because I'm sure there have been presentations about general reverse engineering that have mentioned it. But with Ghidra, we can statically analyze a disassembly of the program. And so we can look at actual game code and see what it's doing instead of just kind of assuming what it does. In the DLL project that I showed you on the previous slide, we just have the function information, but we don't actually have any like implementations. Those are just all the addresses, all the RVAs that point to the real functions. So we actually don't have any information there. We can just have the ability to call to use that information. So now to get a Ghidra environment, what you're going to want to do is we're going to run IL2 CPP inspector again. This time you're going to want to click Python script for disassemblies. And so this part gets a little bit kind of confusing because Ghidra is going to be not going to want to work with us here. But you're going to export the project, and what's going to get exported from this project is a Python file, a Python script, and a .h file. You can name them whatever you want, but we're going to want to keep those because we need to use them inside Ghidra. So now what we're going to want to do is you're going to want to open Ghidra. You're going to want to create a new project, and you want to add the gameassembly.dll. And if you remember, that could be found in the same folder as the Among Us executable. So we will create a new project, add the gameassembly.dll, and then you're going to want to open the code analyzer, which is that little green dragon button. If you can see right here where my mouse is. Now, if you open the file menu, you can click parse C code, and then this is where you're going to want to add the .h file that I mentioned earlier. That .h file is going to be massive. It's going to have every single type def like in the entire game. So it's going to be this giant chunk of a thing. So you can see here, this is the menu that's going to pop up when the parse C source menu comes up. You're just going to add, with this little plus arrow, you're going to add that .h file that was the result. Then you want to add these two arguments to the parse options. And then all you have to do from here is click parse. So this is actually going to take a really long time. On my workstation, which is like pretty modern, it took like 45 minutes, I think. So it's a huge file. So now, after this, the parse C source, it should just go away, and you'll notice nothing's going to be going on. So now, to actually get the disassembly for the game, you're going to have to click on this script menu, which is this little plus or this little arrow up here. You want to add a Python script to Ghidra, which you can use with this little red plus arrow. You'll add your results from IL2 CPP inspector. So I mean, you'll name it whatever you want, but that Python file is what you're going to add to the game or to Ghidra. And then after this, you'll just run it, which is this little button right here. And so this is going to take a really long time. So I actually don't even know how long it took because I think it was like over an hour and a half, and I just kind of left my computer and did something else. But this is actually going to be decompiling the game source, which is in gameassembly.dll. So now you'll actually have a fully fledged reverse engineering environment for a Unity game. So now, you can see here in the bottom left, I just searched for murder to see if I could find like a function that murders people, and there it is right there. Complete disassembly of the murder function in Among Us. So I mean, there's tons of possibilities. You could look for literally anything inside the game. So now there's one more tool that we actually need to use, or we don't have to, but it's pretty useful, called dnspy, which is a .NET and C# debugger. So we could actually use this to edit assemblies, but usually with Unity games, this isn't going to work because a lot of that information is going to be through interfaces. So it's just going to have function and class definitions, but no actual implementations inside of it. Yeah, as you can see there, there's not going to really be a ton of information, but you're going to be able to see all class definitions. And actually, what ended up happening to me was Among Us updated like 2 days ago, or like 2 or 3 days ago, and they actually obfuscated all of their function or class names. So as before, you can see all of these like weird just jumbles of letters. They used to be real class names of the objects inside the game. Now it's just garbage. But I mean, you can still figure out what they are based on what's inside of them. So to actually load something into dnspy, it's pretty simple. You just download dnspy, run it, and then you'd open the file, or you'd click open file and choose the gameassembly.dll, and it'll load in another DLL called assembly-C#. And this is where all your the code that you're going to want to look at lives. So you can see, like, even after the obfuscation, there's still a ton of information here. Like, look at these function signatures I found. Update color, updating game data, hat, update pet. You could give people pets who actually didn't pay for them. It's pretty crazy, updating people's skins. And these are actually all the RVAs that point to them. So this is one way to get RVAs out of the game. And you can see, all these other random variables here that it can, you can use. So the general flow that I like to follow when I'm going through this is I start with dnspy and I kind of just search for like an interesting class. Like there's a class called or was called player control, and it had a ton of useful functions like teleporting players and killing players, things like that. So that's generally where I start. Then I find that same function in Ghidra so I can look at a decompiled version, actually look at what the code is doing instead of just going based off of its name. So I'll reverse it a little bit, and then I'll actually test it out in my DLL project. So then I'll go into my my DLL project that was generated, and that function, you can just call it, and then, since you know what it does because you reverse engineered it, you will actually be able to do very interesting things in the game. So you can see here all the obfuscation that they added, all these like garbled up garbage function names. It'll have the same names in Ghidra, so you literally just would copy paste this into Ghidra and find it. You can see it also provides the RVAs and the offset from the bases of the class. So tons of useful information. So there's only one more thing that I want to go over that is a useful tool. It's called trampoline hooking. So trampoline hooking is the process of injecting into another process, or you inject a DLL into another process, then you inject your own function inside of another function. And so what we could do to achieve this is we would overwrite the first few bytes of a function in the game. So what we'll have to do is you'll save out that information. So you'll have to save out all the register information. You'll have to save out calling convention. You'll have to save out those actual bytes that you're deleting. You'll replace those bytes with an unconditional jump to your own code, as you can see here. So you'll replace the first couple bytes of the target function, and then you'll have you'll call your function that you wrote, your user callback. Then what you have to do is execute that code that you stole. So what you're essentially doing is you're replacing this code with yours. So you still have to execute the function the way that it was originally intended, or the game's gonna, or it's gonna crash. So you execute that original code, or like a lot of people like to call that the stolen bytes, and then you trampoline back to the regular function right after the unconditional jump that you placed in there. So this is extremely useful because you can hook into any function you want in the game. So let's say you want to like modify behavior. Let's say you want to count something, like every time a player dies, you want to increment a count. So in the function that deals with killing a player, you can hook that function and then increment a counter in and then return back to the normal function. And so, you could get all sorts of useful information out of that. Another thing that is really good for that is hooking into graphics API functions. So this is where that RenderDoc stuff kind of comes in handy, because if you know the graphics API that it's using, you can figure out which functions it's using to render just by Googling like that API. And so some of these functions you can find out will only be executed once per frame. So if you want like frame by frame logic to happen, custom logic, like let's say you want to render a GUI to the screen, or you want to render custom objects into the game. If you want to do anything frame by frame, you can hook that API function and then do whatever you want. And you'll see in the demonstration that I'm about to show you that this is what I actually did. So now I'll actually show that demo that I had. So you can see here, I'm going to run Among Us. now that it's running, I'm going to run or get into a game. Feel free to join too, because this will be interesting. I'm going to run my injector. And now you can see I have this little GUI here that displays all sorts of information about me. So you can see it gives me my color, and it'll change based on that. This will also show every other color, every other person's color in the game. It will also show me who's dead, who's alive. It'll show me the second somebody dies. So another fun thing I like to impersonate, which hopefully it still works after the patch that they did a couple days ago, is this impersonation here. I'm actually going to, yep. So see, I made it so you can turn into other people and pretend to be them. Changes you, same screen or same colors, everything. So can switch back. Now I can be here. Switch over here. So there's a ton of possibilities. This is just kind of like something fun that I like to do. I actually I had something to, kill yourself, kill other players, things like that. But that kind of ruins the game. So I took it out just to do fun stuff like this. Well, we actually have 4 people now. So here, I'll start the game and I'll show you. It'll tell me who's the imposter. So Kat is the imposter. She's pink. So you can kind of see right away. And if she kills somebody, you'll see that person's status change up here. Let's see, now it says Lime is dead. So it's just tons of fun information like that, going around impersonating people. It can get pretty fun. So definitely recommend, kind of digging down deep into it. A lot of this presentation was just like a high level overview because the topics actually do get really deep. But yeah, so that is it. So if there are any questions, you can go ahead and start asking them.
Can you impersonate a dead player? Like what happens when you do that?
Yeah.
Oh,
looks like I can. So what it's doing when I impersonate is it's just straight up copying information. So like in one of those slides you saw there was like a all player list. I'm just using that all player list, and there's literally just like a couple integers that represent your skins. So like, or like all the customizables you have on. So I just copy that from one player to the other. And then I also copy this string over.
And then there's some questions in the chat. So Owen asked, can you auto solve tasks?
Yes. So, I mean, you could do whatever you want, actually. Like, you could auto solve tasks. You can kill every player in the game instantly. You can make players not able to press the button. You can teleport players outside the map. You can get complete control of the game. I actually have the source code here. Probably be a bit too much to go over. But if anybody has any specific questions, like technical questions about, how I'm doing certain things inside the game, I can show them the code. For some reason, the chat is not popping up for me, but oh, here we go. Oh yeah, and so it is in MGUI. I see somebody saying, yeah. So what I'm actually doing here is I'm hooking into the game uses DX11. And so what you can see here is DX11 uses a function called present. This is the type def for that function. So this is called once per frame. This is what displays like whatever is being rendered to the screen. So all I have to do is make a copy of this function, which happens here. I make a copy of this function, then I hook that function. I put my copy in that inside of the other function so that now my function gets called every single frame. And so I have all this MGUI code here running basically every single frame.
What I don't understand is why isn't like I think someone asked it in the chat. There's no like server side verification for this game.
Oh no, yeah. So no, this game's pretty trash about that. Like your server runs on your local computer, and it's like doesn't do anything. And like it actually the only thing it checks is if you're the host or not. But you can just spoof that. Like it literally just checks a net ID. So and there's a function to get the net ID of the host. So you can just get the host net ID, and then instead of calling the function normally, just call the function with that host ID, and it'll run perfectly fine. So yeah, I mean that's just this game. Obviously, you'd have to do something else for like an actual AAA game that has security. This game has none, and you can do pretty much whatever you want.
Is your little debug window considered part of Among Us's window, or is it its own thing?
Yeah, no, it's part of Among Us's window. It's being rendered in the same context. Yeah.
All right.
Yeah. So if you were doing an external hack, you'd probably like this would not be part of the same thing. But since I hooked into their rendering API, it's going to be part of it.
Makes sense.
Yeah. If anybody has any other questions, feel free. So AAA company would probably, for one, DLL injection, they would, this, like I mentioned at the beginning when I mentioned the DLL injection, this is like the most naive way to do DLL injection. So they would sniff that out immediately, and they would probably just ban you immediately, like on the spot. It's kind of insane how the bigger engines like Unreal do that. Some other things they would do is to prevent hooking. I'm actually using a tool for hooking functions right now, but the way I described it is like you'd overwrite the first couple bytes of a function, and then you'd save out all the parameters, save out all the registers, and then use them back, or restore them when you want to go back to that function. They look out for this, so they'll actually have little false values at the beginnings of functions that if they get overwritten, they will know that you're trying to hook into their functions, so they will quit. The popular anti-cheat stuff, they will like just straight up encrypt every single byte of the executable, even as it's running. So, I mean, you just have to try to get like a broken key or, something like that. Try to break the encryption. Oh yes, and definitely server-side verification. They would almost definitely be checking to see if bogus information. Another thing is a lot of information. There's like too much information on the client. Like when I'm out of vision of people, it still tells me where, or like inside the game code, it'll actually still hold the positions of every other person in the game. So like even if I don't see a player, it still tells, like my client still knows where they are. And you should definitely not do that, especially in competitive games. Because that's like if you're playing CSGO or something, your client knows where every single person is. You can script like highlight enemies or something, or shoot through walls and just kill everybody or something. It's a stupid thing to do. Let's see. So hacking console games, you'd have to run. So with Xbox, it's a little bit easier actually, because it actually is running Windows 10. It's just running a modified version of Windows 10. So you can actually get like it's not, I don't want to say emulator, I forgot what the name is, but you can actually get a tool to run, and it comes from Xbox themselves, but you can run your Xbox games on your PC through like a little thing just to try to do that. PS4, it's kind of a bitch on PlayStation, honestly, because they have their own proprietary hardware. They have their own proprietary graphics API too, and like the documentation is terrible. Like the only real way to get the dirt documentation is to like apply for a game developer's license with them. It's just a whole mess. So if they have kernel level anti-cheat, I mean, probably you just have to try it. I don't even know. What do you mean by DLL inject at root level? Because there are a couple different methods. Oh yeah, I mean, yeah, some anti cheats, yeah, they basically rootkit you, but I just mean like, what did you mean by kernel or DLL inject at root level? You can actually, so instead of hooking into the network calls, so that would still be part of the game code unless you're hooking into like the Windows API functions that those are calling. That might work. Um, I'm not sure. I haven't tried it, but you can also just packet. You can packet sniff and like edit the packets as they're going out to the game server. That's one way that I've heard people do. Yeah, I'm not 100% sure about the DLL stuff. I mean, you'd probably have to try it out. Yeah. There any more questions?
Do you have any recommendations for the Among Us developers to fix their game from being hacked?
The thing is, like, I know they didn't put a lot of effort into preventing hacks because I don't think they thought this game was going to get big, and it wasn't big for like 2 years. Um, I think now it would be kind of a pain. They could add an anti-cheat. The problem with anti-cheats is like they're basically viruses. I'm sure you guys have had to download them for some games. Is like if you play Valorant, that game straight up installs a rootkit on your computer, and that rootkit that it installs on your computer, it was actually having problems with this hack I was writing. Like it watches every single process and it tries to like sniff out like suspicious things. So like I was doing some hacks for Among Us, and I tried to start up Valorant, and it was complaining and saying that I had some like fraudulent information. So it's kind of ridiculous there. Yeah, I mean, they could add anti-cheat. They could add, I mean, obfuscating functions doesn't really work too well. I mean, Unity has built-in anti-cheating methods, like I mentioned, the one that prevents hooking. So you'd have to hook at like different parts of the function, which is like exponentially more complicated because you like the register states and program state is a lot different. It also has built-in DLL injection, like detection. So yeah, I mean, they just kind of have to put effort into it. It's all built into the engine though. It's like they don't have to do it's on. So EA actually doesn't have an anti-cheat engine. So we can't, I'm not going to say we because like I'm not representing them here, just to make that clear. But EA does not do that. They just hire another company. I'm forgetting the name, whatever it's called. It's pretty popular. I know people get really mad whenever it's brought up, but I can't think of the name right now. Yeah, Denuvo. That's what it is. Yeah. So I mean, Denuvo, you just kind of like pay them, give, and they'll encrypt your game essentially. I mean, I think it depends like game by game basis. So I'm actually on an engine team. So I do graphics. So I can, it's not really like specific games that I work on necessarily. Like I kind of switch around a lot. Like I just did Madden, but yeah, Halo Infinite. That's definitely what EA is working on. But I mean, if you want to try to get into a game server, that's on you, man. Like that is almost definitely illegal because that is running on their hardware. You know, somewhere like there, if that is gonna get you in trouble right there, I would not recommend that. But yeah, I mean, I'm sure it's possible. It's just any other like server that's open for, you know, open to the public. Oh yeah, I know. I mean, so like if you were like, if you did actually get into their server, I'm sure you could do more things. I mean, you'd probably be able to ignore like server-side validations and things like that. Because I know like, oh yeah, you can see my cat. Yeah, he's sleeping over there in the window. Yeah, I know for games like League of Legends, they have like pretty insane server-side validation. It's actually one of the best that I've seen. And so, I mean, I guess you could modify that if you got into their server, not sure. But I mean, you'd have a whole pen testing team, or not a pen test, you'd have a whole blue team on your ass if you did that. Yeah, so if that's it for questions, I guess I'll hand it back over to Claire.
All right. Thank you so much, Paul. We really appreciate your presentation and you being willing to give it. If you guys have any additional questions that you think of in the coming days, Paul is on our Discord. So, I mean, obviously don't harass him with a ton of messages, but if you have like a question relating to the talk, I'm sure he'd be willing to answer it. So you can use one of our channels to ask him a question, or you can directly message him. So everyone just give a thank you to Paul. I see lots of people doing that in the chat. Like I said, we really appreciate you giving this talk because it's not a topic that we normally have someone be able to present on. So we really appreciate your experience.
Yeah, no problem. I could also send the slides, I'm guessing to you, Claire, and you can give it to whoever. But
sounds good. Yeah,
that'd wonderful. Yeah, because I know a couple of them I went through quick, and it had like a lot of information on it. So.
All right. Yeah, if you don't mind sending those to me after the meeting, then that'd be great.
All right, sounds good.
All right. I don't have anything else for you guys, so we can kind of end the meeting here, and you guys can keep an eye out for those slides, and then I will also be posting the recording of this meeting on our club YouTube. So if you want to rewatch any parts of it, you'll be able to. So just keep an eye out on the UFSIT Slack channel and the UFSIT general Discord channel, and you'll see those messages with that content. Thank you everyone for coming out, and I will let you all go.
Thanks. Have a good night, everyone.